Hi everyone, this is your math guru. Today we're going to learn how to use the reduction formula to solve the following trigonometric expressions. In the first example, we have cos 90 degrees plus x times sine 180 degrees plus x, all divided by tan 225 degrees minus cos squared minus x. We're going to be using a cast diagram. We have a C, A, T, and that's S. I'm going to correct that quickly. S and T. In the first quadrant, this is our first, second, third, and fourth quadrant. In the first quadrant, we have x, and where x is an acute angle, we have 360 degrees plus x if there's a complete revolution, and we have 90 degrees minus x. In our second quadrant, we have 180 minus x, or 90 degrees plus x. In our third, we have 180 plus x, and in our fourth, we have 360 degrees minus x. Going back to our example, cos 90 plus x falls in the second quadrant, and using the trig identities, we know that cos 90 degrees, I'm going to show you the relationship between cos and sine quickly, minus sine x, and if we have sine 90 plus x, this will give us positive cos x. So changing as cos 90 plus x in the question, it's going to be minus sine x times sine 180 degrees plus x falls in the third quadrant, and the value of sine in the third quadrant is negative, so that will be minus sine x over tan 225 to 5 is the same as, if we check, 2 to 5 falls in the third quadrant, so we are going to reduce that to tan 180 degrees plus a 45, because 180 plus 45 will give us 225, and if we further reduce that, that will give us positive tan 45 degrees. So if we replace that in our example, we're going to have tan 45 degrees minus, for negative angles, we have sine minus theta equals minus sine theta, cos minus theta equals cos theta, and tan minus theta, which is a negative angle, equals minus tan theta. For negative angles, only cos is positive. So changing that in our equation, we have minus cos squared minus theta will give us cos theta. So that's cos squared x. If we keep simplifying, minus times minus, that's positive. Sin x times sin x, that's sine squared x over tan 45, that's 1 minus cos squared x. In our trig identities, we have sine squared x equals 1 minus cos squared x. We got that from sine squared x plus cos squared x equals to 1. So if we change that in our expression, we are going to have sine squared x over sine squared x, and sine squared x divided by sine squared x, that will give us 1. Let's look at another example. In this example, we have sine 360 degrees minus x times tan minus x, all divided by cos 180 degrees plus x times sine squared a plus cos squared a. We're going to be using the same cast diagram. We're using the first example. Sine 360 minus x falls in, 360 minus x falls in the fourth quadrant, and only cos is positive, so our value of sine here will be negative. So that changes to negative sine x. For our negative angles, tan minus x is the same as minus tan x. So we have minus tan x over cos 180 plus x. 180 plus x falls in the third quadrant, and only tan is positive, so the value of cos will be negative. So we have minus cos x, and from the trig identities, we have sine squared theta plus cos squared theta equals to 1. Theta here is a in this example, so that changes to times 1. Also, the trig identity states that tan theta equals to sine theta over cos theta. So identifying that in our expression, theta minus times minus, that's positive. We are left with sine x over minus cos x times tan x. Sin x over cos x, that's tan x from our trig identities. So that's going to change to minus tan x times tan x, and tan x times tan x, that's tan squared x. Let's look at one more example. In the last example, we have cos 90 degrees minus x times sine minus x, negative angle, divided by cos squared 180 plus x. 90 degrees minus x, that's the first quadrant, and all the trig functions are positive. So this becomes cos x times negative angle sine minus x will give us minus sine x all over cos squared 180 plus x. 180 plus x falls in the third quadrant, and only tan is positive. So this will give us minus cos x all squared. If we simplify, this is going to be cos x times minus sine x over minus cos x times minus cos x, which is the same as cos squared x. This cancels. We're left with the minus cancel each other. We're left with 1 at the bottom, and our final answer will be sine x over minus cos x. Our trig identity states that tan theta equals to sine theta over cos theta. So changing that in our expression, this is also equal to minus tan x. Thanks for watching. Bye.